I'm Dan Vergano. I'm a Scientific American. So
Nice to meet you. I'm Jackie Townsend. I'm the Roman Deputy Project Manager.
Very good.
I'm Nick Alexander. I'm the Managing Editor of Space Scout.
Nice to meet you.
Hi, Jeff Out, Space News.
Nice to meet you as well.
So, how are you doing?
It's a really exciting time. We are all really proud of how far we've come and how close we are to launch.
So you can talk about what's between now and the actual launch. What do you have left to do to prepare the spacecraft, ship it to the cave, etc.?
So we've just finished our comprehensive performance test that happens after environmental testing, and that all went really well. It was, I think, 4 days of round-the-clock testing of the system and our team, both. And there's, as you know, some closeouts, blanket closeouts, last double check on deployments. There's a couple of solar array repairs that we'll probably do. And then starting in early June, we go ahead and pack up to be ready to ship by mid-June.
What does testing those deployments actually mean? Like in my head, it's you unfolding everything and back and forth, but I know it's more complicated than that.
So most of our post-deployment tests are already done, and they are a combination of using the actuators, the non-explosive actuators, in order to do the deployments, right? And then some walkouts. So our high gain antenna deploys. That's complicated because it's hard to do the G negation and the alignment on the ground. That is done and worked great. The solar array walkouts were last week. That's why it's still sitting there with the solar arrays out. And we've done the deployable aperture cover that that one was, sorry. The post-flight test post-environmental testing has been complete, but I think we're gonna do it one more time. And that one will be a walk out, but it's up.
Talk me through the commissioning phase once we're in space, separated from the launch vehicle. What is that going to look like as we sort of get out to its final destination?
So from launch to our insertion into our final Sun-Earth L2 orbit is a little over 100 days is when we start doing that insertion orbit. Our commissioning timeline that happens in that early op phase, right? Launch early operations phase, is currently book kept at about 90 days. And the first half of that, 45 days-ish, is checking everything out, right? So you do the deployments, you cool down the instruments, you do the outgassing stuff, right? And then once all of it sort of is functionally working, then the second 45 days is the on-orbit commissioning to get it ready for science operations. So there's some calibration work that doesn't happen until you're actually in orbit. Everything's at its operating temperature and you're observing the targets that you're planning to observe. And that's when you do your final commissioning and get that data into the pipeline, the algorithms that we'll use to process the data when it comes down here. So that's the second 45 days. And talk to any of the scientists that are here today, they'll tell you much more. Actually, Jeremy Perkins is one of our SMEs, so if you want to talk to him.
Great, thank you.
One of the things we've heard consistently about Roman is that it's ahead of schedule, it's under budget. How did you, since that is not common for a large NASA mission, what are sort of the secrets to achieving that? What did you do to get ahead of that?
So there's unfortunately no one thing, right? We have kind of standard management practices that we do at NASA that I think we're known for, how we balance on the technical side of things. Something that we've done on Roman is we added the programmatics to that balancing equation. So everybody from the project manager all the way down to the techs on the floor understand how the cost and the schedule and the technical all have to come together on Roman. So when we have a really robust set of processes that, again, it's kind of wonky, but we have a risk management process, and it's not just turning the crank, right? It's a set of conversations where we're all talking about the technical risk. Is this something that if the risk was realized, like if a deployment didn't work right after environments, would we accept the risk and fly that way? No. If a deployment didn't work, it would become a programmatic risk, right? We would accept the schedule hit and maybe a budget hit in order to fix that problem. And that's not how we necessarily always think about risk at NASA. We tend to think very robustly in the technical side, and on Roman, we've expanded that field of view for everybody on the team to try to take it all into account.
Is that an exportable model going forward? I mean, should GAO be studying this as a case study, or is this just a happy mission?
No, I think there's lots of lessons that we can learn on Roman. I mean, another one is, I think you all know, Roman was cost capped essentially when we were approved to proceed, and that is very unusual. And that cost cap came with, again, a little wonky, the funding that came from Congress, that Congress gave to NASA to complete Roman, was forward phased. So we were never at the end of a single year, we were never in a cash flow problem. We were investing the money from 2020 in buying down the risk for the integration and test flow that happened in 2025, right? So that combination of a cost cap and forward phased funding allows for smart decisions all the way through the life cycle. So there are plenty of things that we can talk through. And in fact, we're doing a knowledge capture exercise, so that's why I can name these two things with confidence. But there's a lot, and we are working to make sure we capture them now while the team is still here, and then working on exporting them to beyond NASA even, if folks are interested.
So Goddard has had a long history of supporting telescope missions. Talk to me a little bit about the culture of, building and maintaining and working on telescopes, and why that makes this team work.
Boy, that's a great question. So I worked on the Hubble Space Telescope mission, so I'm one of these people. And on Roman, where I see that continuity most clearly is in the detectors, right? So the Roman's 18 4K by 4K H4RG devices that are kind of the heart and soul of what we're going to do with Roman. Those were built on a legacy that started in 1998 with the H1RGs that were built for Hubble's Wide Field Camera 3, which is what I managed. And even before that mission launched, that instrument went up into space in 2009, the Roman team, which was then W1st or JADM, even before it was selected, were working with our same partners, Teledyne and Hawaii Aerospace, and Goddard's detector calibration lab, to start maturing that technology so that when it was finally selected out of the 2010 decadal, the key enabling technologies were already on the path to being TRL-6. So that long-term thinking, there were investments made in Goddard's detector characterization lab as far back as 1998, and we did not shut it down and then try to recreate it for each mission as it went, right? There was a commitment at headquarters with IRAD funding and with multiple missions so that we could retain and keep growing that expertise, so that when we got to Roman, instead of 164 devices to fly one, it was 119 devices to fly 18 in our flight run. So we look for opportunities to build that knowledge instead of it always being a miracle occurs, this big disruptive technology. We try not to bet on those things when it's a $4 billion bet.
What at this moment takes most of your time? Like at this, you're so close. It feels like to us, at least, or maybe not to you, but like.
Oh no, it feels very close. So at my primary responsibility on Roman is that connection to up and out, and that can be at Goddard, that can be with you guys, that can be with, and most often it's with our headquarters stakeholders, to make sure that we're all staying aligned about the work that's ahead. And on because Roman is doing so well technically, it's not a lot of conversations about what's happening technically with Roman because we're on track. It's a lot about how are the guest ops going to go, how is media day going to go, right? And making sure that we're telling the Roman story because we think it's engaging and interesting, and we want to make sure that that we're telling the truth and getting the message out.
When you ship it down to the Cape, what sort of final processing do you have to do, fueling, things like that, to actually get it ready for launch?
So I'm not the expert on this. I kind of only know in general terms, right? When it's shipping on a barge, we get it down there. The first thing you do is slowly unpack and get it in, and then you do short functional tests to make sure that it survives shipping without making any changes for this last 4-day comprehensive. test. And we have a couple of what we call MRT, mission readiness tests, where we're actually connected to the flight system, and we run through the launch day again and make sure that people are ready and that the system is still working ready, and all the procs we've written it's kind of their final chance to do that. And then it's the operations with SpaceX to fuel and get encapsulated and launch.
Do you have an estimate for a day of launch yet, or is that still kind of in work?
It's still not later than early September. Obviously our attention right now is more on the ship date, which is in mid-June.
We'll be close to a wrapping point, so we can start swapping some people around.
Go find Jeremy, sorry, Jeremy.
That's okay with you guys?
Yep.
All right. Thank you for your time.
Do you want me to leave and somebody else comes in here?
No, why don't we do it the other way
Okay.
around? If that's